Hello Forensic Science, this is Mr. Russell here to show you a few things about bloodstain patterns. I filmed some videos to show you guys how to do this because I'll be gone today, well tomorrow for me, today for you, Tuesday the 21st of October because I'm writing curriculum for the science department. So anyway, first thing we need to talk about is area of convergence. Okay, first of all, blood travels predictably. We've talked about this before. It's pretty much always the same consistency, and because of that, it behaves predictably. Once you figure out what it does, you can assume that it's always going to do the same thing. Okay, so last time we talked about passive bloodstains, which are those that fall straight down and you get a round pattern, okay? So they are as wide as they are long. What we're going to talk about today is when something is moving laterally. Okay, so when it's traveling sideways, you end up with what's called an elongated bloodstain, right? And that means it's long and skinny. Okay, and you can figure out which direction it's moving because we know that the fat part of the droplet is where that blood droplet hit first. Or I guess I should say the fat part of the stain is where the droplet hit first. And then this little spine and the satellites that come off of the other end, those show you the direction the blood droplet was moving. So we know that's what that arrow means. Okay, so a lot of people get confused and think this fat spot is the direction it was moving. It's actually the opposite. That's where it hit first, which means the blood was going that way here. Okay, so if we have a bunch of droplets and we think they were all produced by the same impact, we can use those to try to figure out where that came from. Now, to do that two-dimensionally, we use what's called area of convergence, or I guess we're finding out what the area of convergence is. And what we do is we find our elongated droplets, and what we're going to do is draw lines that go down the long axis, so not the small axis, but the long axis of the drop, and these lines should go the opposite of the direction of travel, because we don't want to know where the blood's going here, we want to know where it came from. So, you'll see they did that here. We had one droplet, they have a line that comes up here, another that goes there, and a third that comes down here. And where those lines intersect is called the area of convergence, and sometimes you will see it referred to as the point of convergence. Okay? Let me show you an example of that on the board. Okay, drew some blood droplets over here. Not very good, but that's okay. And I'm going to do exactly what I said. So, long axis, the fat part's here, the spine, and then I don't have any satellites, but they would be out in this area. So we know the blood droplet had to be moving that direction, and this one was moving this direction, and this one is moving that direction. So, I'm going to trace down the long axis of my poorly drawn blood droplets. There's one. There's two. And here, oh, fumble, is the third. Oh, falling apart here. Okay, they're not all going to cross in one perfect point, but what you're going to end up with is a small area where these things cross one another, and that is your area of convergence. So you're going to be figuring that out today on a sheet that looks like this. You'll notice that you have much smaller droplets, but they are still elongated. So follow the directions. You're going to have a bunch of stains, little droplets, or a bunch of stains from little droplets. You need to pick 5 of those. I would get a variety. Get some off on the left and some off on the right, some far away and up close, and find out where they converge, and hopefully you end up with an area about the size of a quarter. That's how you figure out area of convergence.